Hello, everyone. Thank you for joining us at Industry Tech Days, brought to you by EE Tech Media and All About Circuits, in partnership with Electronica and sponsored by DigiKey. My name is Dale Wilson, and I'll be your moderator for our next session. This live session is titled Learn the Benefits of the Ideal Switch for RF and Microwave Applications and is brought to you by Menlo Micro. Let me tell you a bit about our presenter. Simon Liang is the RF Product Manager for Menlo Micro and has held multiple product management and RF design roles within the wireless, automotive, telecom, aerospace, and defense industries. Based in Menlo Micro's headquarters in Irvine, California, Simon manages the company's RF and microwave product portfolio and oversees the company's product development efforts. With decades of experience in electronic systems and semiconductor industries, he is contributing to the expansion of Menlo Micro's Ideal Switch product portfolio. I have a couple of quick housekeeping items before we jump into his session. Following the presentation, we will have a live Q&A with Simon. You can submit questions using the chat box on the right-hand side of your screen at any time during the presentation. So please stick around for the Q&A, as we'll be announcing the winners of this live session's giveaways before the session comes to a close. We will also provide the attendees with a PDF version of the presentation you see today near the end of our session. So thank you so much for joining, and with that, I'll hand it off to Simon for the presentation. Welcome, Simon.
Hi, I'd like to present today's seminar topic, introducing the benefits of Ideal Switch for RF and microwave applications. My name is Simon Liang. I am the product manager for RF and microwave at Menlo Microsystems. I have held multiple product management and RF design roles in the wireless, automotive, telecom, and aerospace and defense industries. Currently at Menlo Micros, I am managing the product portfolio and roadmap for RF and microwave. So for today's seminar agenda, I'd like to give you a little bit of an idea of what Ideal Switch story is about, how Ideal Switch works, the advantages of Ideal Switch, RF and microwave application benefits, and with some concluding remarks. The Ideal Switch story began over 100 years ago when Thomas Edison invented the circuit breaker. General Electric combined his invention to reinvent a circuit breaker using MEMS switch technology. GE then heavily invested in the material science R&D in order to solve MEMS key technical challenges, such as how to reliably operate a MEMS switch at high temperatures. After successfully overcame the MEMS challenges with the desire to expand into wider commercial opportunities, GE formed and spun off a startup company called Menlo Microsystems back in 2016, which is headquartered in Irvine, California, and with R&D and factory in New York. To this date, Menlo has shipped over 600,000 Ideal switches across industries such as test and measurements, aerospace and defense, telecom and wireless, consumer, and medical. Since Menlo Micro was formed in 2016 to address the wider market demands, Menlo Micro has further refined GE's MEMS switch invention to develop an Ideal Switch platform for the RF and microwave application that focus on three key markets: test and measurement, telecom and wireless, and aerospace and defense. With a host of RF performance advantages, the Ideal Switch has enabled application across these markets that depends on high-performance RF switches in order to provide a robust and transparent RF signal integrity for the RF channel RF system applications. So how Ideal Switch works? Well, Menlo has successfully combined the innovations of MEMS switch design itself, the semiconductor processing, and most importantly, the glass-based packaging technologies in order to form the basic building block of an ideal switch, which really is a 50 by 50 micrometer unit cell, as shown in the picture above. The cell itself consists of 4 elements: an alloy beam, contact, a gate pad, which are then plated onto a glass substrate with a glass cap. The ideal switch unique capabilities and features are, as shown on the right. First, beam and glass, which enables high RF power handling with low RF loss. Second, the through glass via, which provides high frequency response. And third, unit cell, which forms the scalable 2D switch array, which I'll show you with a few more slides later. Fourth, a 2D switch array and system in glass SiG package, which builds up the versatile and highly reliable RF switch portfolio. Since ideal switch unit cell is a normally open switch, actuating or closing it will require a 90 volt DC applied to the gate pad through electrostatic mechanism. This slide visually illustrates how a scalable 2-dimensional switch array is constructed in order to build the versatile RF switch configurations for the high RF power and frequency capabilities. The switch array can be scaled in series for voltage and power, then scaled in parallel, which is shown arrow down, for current and power. The switch array and the through glass via are then plated onto the glass substrate in order to form the system in glass, SiG, as the key MEMS switch unit or element, which is manufactured in a wafer level chip scale package. The diagram to the right illustrates a single pole 4-throw switch where each switch port is scaled with 2 cells in series, 4 cells in parallel, for a total of 8 unit cells. So for the 4 switch ports that's shown, a total of 32 unit cells is configured for Menlo's MM51 series RF switch portfolio. This slide visually illustrates how ideal switch system in glass, or SiG again, becomes an enabling element for the advanced heterogeneous integrated circuit integration with other electronic, RF, and glass-based components, as shown to the right. In addition, the ideal switch system in package, SiP, consists of SiG, which is the glass element, the key MEMS switch element, and it can be integrated with CMOS-based high voltage driver chip inside the land grid array, or LGA, or a ball grid array, BGA IC packages, which constitute the majority of our current RF switch product portfolio. So the SiG and the SiP is shown on the picture above with the Menlo micro label on it. The ideal switch capabilities highlighted on the previous slides is the building block, as I mentioned earlier, of Menlo's current switch product portfolio that is in production. The portfolio is targeting the 3 key industries and applications. However, the ideal switch scalability and configurability that was shown earlier slides allows for a customizable switch design to address customized applications. The portfolio covers from DC up to 26 GHz, from single pole single throw configuration to a single pole 4-throw configurations, and handles up to 25 watt CW with low insertion loss, and with the ability to control the switch through serial and parallel interface or direct with the 90-volt DC. In addition, the portfolio's industrial temperature from -40 to 85 C can be extended for customized product development and applications. With a market survey on key switch technology across about a dozen leading suppliers, we discovered that although the solid-state RF switch inherits wide frequency band, fast switching, low DC power, and long life, but it's too lossy and cannot handle high RF power, and also it distorts signals with high intermod distortions. So the ideal switch, also similarly, the electromechanical RF switch handles high RF power with low loss, but it consumes more DC power with shorter life, and is too large. So ideal switch inherits the best of both worlds with 6 pillars of advantages, which I would like to highlight. First, high RF power handling up to 25 watts or 150 watts pulse power. 2, low insertion loss of less than 1 dB. 3, high third order interlinearity or IP3 of 95 dBm, which is unmatched in the industry. 4, long lives of greater than 3 billion switch cycles. 5, low DC power from 0.1 to less than 10 milliwatts. 6, small size from 6 to 22 square millimeter. So the advantage of ideal switch, I'd like to introduce a simple RF system analysis to illustrate how RF switch contributes to and impacts the RF system performances. Here, a simple RF system link budget consisting of a black box transmit block with its output tied to a RF switch, which is quite common in many applications. Then ideally wire connected to a black box receive block. So this whole system, RF system link, are assigned with a RF system parameters, just hypothetical RF system parameters that's shown in the table. We then collected 4 key RF switch specs from, and these 4 specs are the operating frequency, RF switch loss, the power handling, and RF switch IP3 or linearity. So we collected 4 of these specs out of 8 leading suppliers, switch suppliers. Their data sheet on the web. And these 8 leading suppliers' data sheet represents 7 different switch technologies, which I'll outline on the next slide. Then we perform a cascaded link budget analysis on the linearity of this link, of this RF system link, and also on the channel data capacity using Shannon's communication channel capacity equation. So for the next few slides, I will summarize how RF system performances are impacted by the RF specs across different switch technologies. So this chart summarizes a two-tone intermodulation distortion, or IMD, calculation for the RF system that was defined in the previous slide. So keeping the RF system transmit and receive block, or the black box parameters that are shown in the previous slides table, keeping them the same. But the IMD is calculated using each of the 9 switches IP3 specs. And you can see the differences across different switch technologies from different suppliers. Since Menlo's MM5140, which is one of our 8 gigahertz RF switch product, the switch has the highest IP3 with IMD margin of from 8 to 52 dB across these different switch technology. So literally, the MEM5140 is adding negligible RF signal distortion to the multiple channel transmit output of the RF system shown earlier on the previous slide, which really is a very, very important thing because it's essential to maintaining a RF spectrum purity for this RF system link in order to enhance the the effective and efficient uses and sharing of this precious FCC spectrum across systems of multiple channel transmitters and receivers. In terms of power dynamics, our system power dynamics, Menlo's MEM5140 switch, the higher rated RF power handling and also low insertion loss together improves the RF system link budget by enabling high power transmitter in order to extend the wireless coverage, for instance, and also eventually to improve the channel data capacity, which I'll highlight on a later slide. And one key point here is the insertion loss is shown on the horizontal axis. So based on the RF switch insertion loss that's shown there, it's translated into the amount of input power to the switch that's lost due to RF power dissipation from the insertion loss. So you can see some of the switch technologies with higher insertion loss are showing a great amount of input power dissipation going into the switch. For the Menlo MEM5140 of less than 1 dB, around 9% of the RF input power is lost through dissipation. Whereas other switch technology with greater than 1 dB insertion loss, you can see some of them loses as high as 30 dB of RF input power going into RF switch through the insertion loss. So as far as the channel data capacity that I brought up earlier, since the RF switch with low IP3, shown on previous slides, degrades multiple channel transmitters RF spectrum purity in the forms of IMD and third order intermod distortions. So effective RF spectrum that I mentioned earlier, uses and sharing requires that the impacted transmitter, the RF power going into it or output of it needs to be reduced in order to recover the same spectrum purity as possibly mandated by the FCC or could be all the spectrum sharing schemes. But also doing so in reducing transmitter power just to keep the spectrum purity, it also at the same time reduces the wireless coverage due to the lower power extending out to the wireless coverage. So in effect, this reduces the corresponding receiver's RF signal, and then eventually the receiver's signal to noise, which also reduces the receive channel's data capacity, as explained by Shannon's communication channel capacity equation. That is dependent on the signal to noise and channel bandwidth. So for this illustration, we keep the channel bandwidth the same. It's a fixed number across all these different switch technology for comparisons. So overall, the receiver's lower channel data capacity also reduces the spectrum efficiency, if you see it that way, because spectrum efficiency is expressed in bits per hertz. And now with this lower signal to noise ratio as a result of reducing the transmit power just to keep the spectrum purity in check. So you literally reduce the channel data rates at the receiver, thereby reducing the bits per hertz spectrum efficiency. So what are the benefits of ideal switch? So on the RF and microwave application benefits, so we all know by now that selecting an RF switch with the best RF performances is essential to maintain a robust and transparent RF link signal integrity and link budget. So as an example, applications such as the RF test and measurement definitely demands such a requirements in order to implement a automated, high density, repeatable and reliable multi-channel RF test beds for testing all kinds of RF components, such as the IC itself, RF IC itself, could be testing devices, passive or active devices, or further, it could also even be used to test some RF modules. So the diagram shown above really is a notional automated RF look back, and also RF over-the-air test beds. Again, this is a fully automated notional scenario where it could drastically reduce the testing OpEx, operating expense, when such test beds are deployed with a very well-designed test bed RF link signal integrity. So in conclusion, for about 15 slides now, we have illustrated how a high performance RF switch does contribute to the RF system with a robust, transparent, and efficient RF signal integrity and link budget. Further, we've also illustrated how a low performance RF switch could impact and degrade wireless spectrum purity, coverage, channel data capacity I mentioned, and of course the spectrum efficiency. So we believe that Menlo's ideal switch, with its 6 pillars of advantages, is an enabling RF switch technology. Thank you.
Well, thanks, Simon, for that great presentation. We already have several good questions from our audience, but audience members, there's still time to submit your questions, so send those in. Simon, are you ready to get started answering some of the questions?
Yes, I am. Thank you.
Excellent. So the first one is, someone is asking, where can they find additional product information on the Ideal Switch?
So the additional information you can visit the menlomicro.com, our website, to find information about the company. There's also information on the technology, the Ideal Switch, namely, the product and resources, and also some recent news of the company, etc. And Menlo Micro also has a free portal for designers, looking for board layout diagrams, data sheets, and all the other design tools that enables the designer for a firsthand evaluation of our products.
Okay, and I really like this question. What have been the most common roadblocks when getting the Ideal Switch designed in? I'm thinking that they're thinking into their own applications. What are the roadblocks people might encounter?
Well, there isn't a whole lot of thing I think in terms of roadblock. The roadblock really is not really fully understand some of the Ideal Switch capabilities and features, such as the one that I think this webinar is trying to highlight, and also encouraging the designers to sort of look at the Ideal Switch specifications more at the system level, much like what this webinar is trying to present, and then start realize some of the sort of the benefits RF system wise, as well as the individual switch capability itself.
Oh, very good. And I should add here before we get to some more questions that the presentation is available for download. Go to the upper right corner in the handouts tab, and you should be able to download the presentation. Next question, is the Ideal Switch currently in production?
Yes, so Menlo Micro has 8 switch portfolio products in production at this time, or today, and we expect the 9th product in production later this week. And at the same time, we continue to work on building out our portfolio of RF products based on our customer feedback and requirements for their designs.
Okay. Next question is, can the Ideal Switch work in millimeter wave frequencies?
Yes. So currently, Menlo Micro's RF switch portfolio covers from DC to 26 gigahertz. At this time, we have new switch product in development that cover up to 70 gigahertz primarily targeting telecom, such as 5G, possibly 6G, and also targeting aerospace and defense applications.
Very good. This question is, how stable is the Ideal Switch's RF performance?
So the Ideal Switch is capable of highly stable performances from DC to microwave frequencies range, primarily over temperature, such as from the industry grade from -40°C to 85°C, and also up to billions of switch cycles. So we have done extensive testing, characterization, and which leading to production of ATSA products. And this highly reliable RF performance is also achieved from a unique alloy material science, as I mentioned earlier, through innovative glass substrate and also hermetically sealed packaging, which really constitutes the innovation behind this Ideal Switch, and which makes the RF switch performances stable across different environments.
Okay. And then here the question is, where can I order samples and evaluation kits? Do you even have evaluation kits?
Yes, we do. So you can order Menlo Micro products through our, either authorized distributors, such as the RFNW, Mouser, and also Breaktor over in Asia. We're also working with possibly future distributor at the same time to expand our reach. And secondly, you can also order through our sales rep across the globe. Our sales channel contacts information can be accessed through our website. If you do go into menlomicro.com, you can click on the upper right-hand side of that homepage. There is a button called Buy Now on the upper right of the homepage. You will have access to the contact information for the sales channels, or you could just simply email sales@menlomicro.com, and our sales team will respond to you.
While we wait to see if some more questions come in, I want to tell people that if they want to hear more about the fascinating story behind Menlo Micro and the development process of the Ideal Switch, I would encourage you to check out the Moore's Lobby podcast episode when All About Circuits interviewed the Menlo Micro CTO, Chris Keimel. Fascinating episode. While we wait for more questions, Simon, do you have any additional insights or anything you want to make sure the audience takes away from your session?
So I think what this webinar is attempting to do is to illustrate how high performance RF switch do contribute to RF system performances that especially for applications that require robust, transparent, and efficient RF signal integrity and link budget, for their specific applications. And we believe that Menlo's Ideal Switch and its the six advantages that I highlighted earlier is indeed an enabling RF switch technology for a variety of switch application needs.
Yeah, fascinating technology. Well, it looks like we've covered all the audience questions. Thank you, Simon, for that excellent presentation and sticking around to talk during the Q&A. It was a pleasure talking with you.
Thank you very much, and thank you for Industry Tech Days.
Before we wrap up, I'd like to announce our giveaway winners for this session. The winners will receive an event t-shirt and a PCB ruler courtesy of DigiKey. Congratulations, Dave Bursky and Nathan Matsui. We'll be in touch with you after the event to ensure we have the information we need to send you those giveaway packages. And folks, be sure to check out the other live sessions happening today and all through the week. You'll be redirected in just a moment to Menlo Micro's booth page where you can browse and access their other content. Thank you for your time, and we look forward to seeing you at another live session again soon.